Hello viewers, in this video I'm going to be solving this equation, which is 3 raised to power x times 5 raised to power of x squared is equal to 15. Now what can I do here? What I can do is to try to see if I can get common base on the individual side. So if I decide to divide this by 5, for instance, and divide this by 5, I'm just trying to tell you what we can do first. 5 will go into 15, you have 3. So we have 3 here. And then I can even divide again by 3 raised to power x. Right? So watch this now. This will cancel this. And I'm now going to have 5 raised to power x squared over 5 is equal to what? 3 over 3 raised to power x. Can you see we have a common base here and we have a common base here as well. So that's exactly what I'm going to do. I just gave you an idea of why I would start by dividing both sides by 5 and then by 3 raised to the power of x. So let's do it again. So divide both sides by 5. Of course, you know why I'm doing that already. So that's 3 raised to power x times 5 raised to power x squared over 5 is equal to 15 over 5. Now 5 here is 1. 5 into 15 is what? 3. So again, I'm going to divide both sides by 3 raised to the power of x. So divide both sides by 3 raised to the power of x. So I'm going to have 3 raised to the power x times 5 raised to the power x over, there's a 5 here already, so 5. And with the 3 raised to the power x, I'm dividing both sides by, so this is equal to 3, then over what? 3 raised to the power of x. So watch this now. 3 raised to the power x cancels 3 raised to the power x. So there's a squared here. Now I'm now going to have 5 raised to the power x squared over 5 is equal to 3 over 3 raised to the power x. So from one of the laws of logarithm, from the negative index law, if you have, say, a raised to the power negative 1, this is also what? 1 over a. So that's the same thing I'm going to apply here. Now watch this. I'm going to rewrite this as 5 raised to the power x squared times 1 over 5. Remember, if you multiply this, you get this back. So I just rewrote the fraction. I'm going to do the same thing on the right hand side. So this will be 3 times 1 over 3 raised to the power x. So from the negative index law, when you have a negative exponent, you can take the reciprocal of that number, giving you 1 over a. So that's exactly what I will do here now. I'm going to rewrite this as 5 raised to the power x squared times 5 raised to the power negative 1. Where is this coming from? It's coming from 1 over 5. Remember, applying the negative index rule. So again, what I have here is what? 3 times 3 raised to the power what? Negative x. Notice it's from here. Okay. Now, from the product rule in indices, since they have a common base, I am going to add the exponent. The same thing on the right hand side. So I'm going to have 5 raised to the power x squared plus negative 1. And here, you remember this 3 has an exponent of 1, even though it's not written. 3 raised to the power 1 plus what? Negative x. So let's simplify that. I'm going to have 5 raised to the power of what? X squared minus 1 is equal to 3 raised to the power what? 1 minus x. Notice, plus minus is what? Minus. Now what am I going to do next? Since I want to bring the exponent down, I am going to take the logarithm of both sides. So take the logarithm of both sides. So that will be what? Log 5 raised to the power x squared minus 1 is equal to log what? 3 raised to the power what? 1 minus x. That's log 3 raised to the power 1 minus x. From one of the laws of logarithm, if you have log a raised to the power b, this can be expressed as b log a. So the exponent here can be used to multiply the logarithm. That's exactly what I'm going to do here. So this will be what? X squared minus 1. Notice is from here. Then times log 5. The same thing here as well. 1 minus x times what? Log 3. 1 minus x times log 3. What am I going to do next? I want to get the value of x. So I'll try as much as possible to get rid of unwanted numbers or terms. So log 5 has to leave, and I'll divide both sides by log 5. So divide this by log 5 and do the same thing here. So log 5 cancels log 5, and what do I have? I have x squared minus 1 is equal to what now? 1 minus x. I'm going to rewrite this like this. Log 3 over what? Log 5 is the same thing as what we have here. So what am I going to do next? I'm going to use the change of base law, the change of base rule in logarithm. If you have log a over log b, this is equal to log a base b. This base is from the argument here. So I just made it to be the base since I am combining both logarithms. Notice this can only work if they have a common base. Of course, since there's no base here, so the default base here is what? Base 10. So that's exactly what I'm going to do here as well. So I'm going to rewrite this. Just watch. In the next line, I'm going to write x squared minus 1 is equal to 1 minus x. And then log what? 3. I'm changing from the default base of 10 to base 5. The 5 is from the argument here. So that's how it works. See, what's this? This is x squared minus 1. I'm still going to use difference of two squares later there. But what is this? 1 minus x. How can I make it x minus 1 so that when I use difference of two squares, it's going to be helpful? I am going to introduce a negative sign here. If I put a negative sign here, I will have to change the sign of the terms in the bracket so that the negative sign I'm going to put before the bracket will counter that change of the signs of the terms in the bracket. So let me write what I just said now. So I'm going to write this as x squared minus 1 is equal to what? Minus, open a bracket and write x minus 1. Notice something. I just changed the sign of the terms. It was negative x, now it is what? X. It was 1 here, now it's what? Negative 1. And the negative sign before the bracket, if you use it to expand this bracket, you are going to get back 1 minus x. See what I mean? Minus times x is minus x, and minus times negative 1 is what? Plus 1, which is the same thing as what we have here. Can you see that? Exactly. So let's continue. Now, what do I do next? I'm going to move this to the left-hand side. If I do that, I'm going to have x squared minus 1 plus, into bracket, what? X minus 1. Remember, if you move the whole term to the left-hand side, you have to change the sign. That's why from minus, it became what? Plus. So that's what? Log 3 base 5. Okay, now, can you see something here? This is difference of two squares. Where's the other square? I can put a square here, and of course, 1 squared is same as what? 1. So let's rewrite this. If you factorize this using difference of two squares, I'm going to have x minus 1, and then what? X plus 1. Then plus this other we have here. Of course, this is equal to 0. So x minus 1, and then log what? 3 base 5 is equal to 0. Can you tell me what is common? Look at the two terms. This one is a term, this is another term. What's common? Obviously, x minus 1. So let's factor x minus 1 out. I'm going to have x minus 1, and then x plus 1. Because if you divide this by x minus 1, you're going to have what? X plus 1. So plus the other one. If you divide this by x minus 1, you're going to have what? Log 3 base 5. And all is equal to what? 0. Now, it's time to use the zero product rule. If you have a times b is equal to 0, it means that either is equal to 0 or b is equal to 0. So let's come here and do this. Since this is a product of two factors as we have here, it means that x minus 1 is equal to 0, or all of this is equal to 0. So x plus 1 plus log 3 base 5 is equal to 0. So what do we have here? If you transpose -1 to the right hand side, you're going to have x is equal to 1 or this other one. Let's rewrite this one under. I'm now going to have what? X plus 1 plus log 3 base 5 is equal to 0. So what do we do here? Let me move this to the right hand side. So we'll have that x is equal to -1 negative log 3 is 5. So this is the other value of x. But let's just quickly rewrite this as, remember, you know that 1 can be rewritten as log 5 base 5, because if the argument and the base are the same in a log, then the logarithm of that number is 1. So the reason why I'm choosing to use log 5 base 5 is because of this base here of 5. I want them to match. So what it is now, I'm going to rewrite this as what? X is equal to minus log 5 base 5, and then minus what? Log 3 base 5. So they have a common sign, which is minus. I'll bring that out. X will be equal to minus, open a bracket, log 5 base 5 plus log 3 base 5. Observe this. If you use this minus to expand everything you have in the bracket, you are going to get this back. Okay. So from the product rule in logarithm, see, they have a common base of 5. Since we're adding, I'm going to multiply their argument and make them a single logarithm. So x will be equal to minus log 5 times 3. Notice from here and from here. And then with the common base that they have, base 5. So this is equal to what? Negative log. What is 5 times 3? That's what? 15. So 15 base 5. So this is the other value of x. Let's call this x2. And what was our x1? x1 was what? Was 1. Okay, let's quickly confirm our answer. Don't worry, I'm not going to use x2. I'm going to use only this to confirm our answer. So remember, x is equal to 1. Let's plug it into the equation. What was the original equation? 3 raised to power x times what? 5 raised to power x squared. Let's see if this will give us 15 when we plug in 1 into this. So that will be 3 raised to power 1 times 5 raised to power 1. Notice x is 1, so raised to power 2. Will this give us 15? Let's see. That's 3 raised to power. 3 raised to power 1 is 3 times 5 raised to power 1 squared is also 1. And 5 raised to power 1 is also 5. So, of course, 3 times 5 is what? 15. So, yes, we have been able to prove that the value of x is 1. And I'm sure the other value is also what we got here, which is what? Negative log 15 base 5. I'm sure you enjoyed this video. Kindly subscribe to this channel for more content like this. And make sure you share this video to your friends and family. I hope to see you in the next video. Bye for now.